Okay, I guess we have enough crowd. Thanks for coming, and hope you had a great lunch. So, hope you all see what is my next slide. Before that, I hope none of you require an introduction to this. I mean, for me. So this is a question time. So, you know, if you've been there for at least back what is it called, sprint reviews and everything, you know how crazy presenter I am. So here comes the question time of this session. So what do you really expect from this topic? You know what is the topic, right? Hope you read that slide before, so I'm not going to repeat it. So what is the expectation for you when we are done with this presentation?
To be able to build a reactive application using Vert.x.
Okay, so if that is an expectation, you can stop here. I'm not really going to give you on how we can possibly do things on Vert.x and everything. But one thing I'm damn sure that what I'm going to do is just to throw some idea on what is all this about and everything. Okay, it is up to you to whether take a chance to build or not to go with this, or go with Go or whatever it is. Okay, so and before that, that's one part of first part of the question session. And the second thing, so what do we do? What are we actually trying to do in all across the team from in these days when we are building application in a large scale? So probably Yuvraj has coined this term a lot of times. So yeah. Okay, so we are trying to do something with microservices and everything. So forget about this microservice for now and just think and let me know and what a modern application architecture should be in these days. Say back then there was one application could be deployed anywhere in the internet. Anywhere in your data server, which could handle some few requests on hourly basis or whatever it is. So, but now these days are not so, right? One best example is Pokemon Go. How many of you heard of it? No? Fine. Okay. If you don't know, it was just a crazy game. It was actually an augmented reality game, and you can just need to go and explore it about. But just that thing, it is unofficially launched in India, but it has a great, and you can't even say how many hits they faced for that given period of time. Even within a day or so, I don't have a stat, but it was so crazy. So when you build applications, you can't on these days you can't expect how many users could reach your application on a given time, right? So what do you want when we build an application? What it's supposed to be? It should be very elastic, right? I mean, you can't predict how the users for certain extents, especially. Hope we have such a good time in our application very soon. So that is really an inherited property when we build in a modern application like these days applications. Right? Similarly, do we have anything else for modern applications? So which is actually current data that we use. Load is one factor. Second one. Come on, just pick something. Yeah, responsiveness. Okay. Which means that if there is a load time, even if it is a load time, you should have a minimum response time for the users, right? Okay, what next?
Should work on low bandwidth connections.
Sorry?
Should work well even on low bandwidth connections.
Okay, the same aligned with responsive time, I guess. So for these as of now, okay. So since we are working on agile principles and everything, I'm trying to a time box. So maybe if I'm going fast, stop me then and there. Okay, so we have some modern applications criteria here, and I would really like to know and how these are actually we are building these days with all these features and everything. Okay, so say an example, we have some X services running out there, and which is supposed to handle only some requests and everything. So we predict that the traffic is growing tremendously, and what do we do next? Anyone from architecture team? Yeah, what do we do? We spin up another server, and is that all? That's it. We need some guy in front of the engineers, load balancer, and we need to attach him, and he is the responsible for splitting the load and everything. Blah blah stories. Hope you all heard about it, right? So how do we manage? So think about one solution. It doesn't really need how to handle all these loads and everything. So if a request comes, just serve. Okay, nothing else. Okay, you really need not to worry about all this load balancing and all this sake of serverless and everything. So it sounds really easy, right? So if everything, all those configurations are what do you say, put out, and if everything can be handled in the code, it would be nice, right? Which means the application itself could handle those things, means would be really nice, right? So that's all. So we have few questions here: how a modern application has to be, and how this sounds like. If it is all done in this way, it would be fine. We have some expectations right now, right? So as I told you, we are not about to tell you how to master in Vert.x out of this session. I'm just going to throw out some few fundamentals about what is this all around, and you can go and build your own if you want. Okay. So getting started with what is reactive. When I say reactive applications with my, Vert.x, I just wanted to tell you what is reactive is. So when I say manifesto, it is yet another manifesto that they're out there in the software development ecosystem. Okay, so like Agile and something like that, OOPS and everything. Okay, so Reactive Manifesto is actually meant for these building modern applications. So this is evolved because we have been developing applications for a long. As I said, like the application we have developed 2 decades ago is not the same architecture or the same pattern we are using now, right? So according to the current modern application patterns that is occurring on time to time, a group of people came together and they actually came up with the manifesto, and they are pushing all other developers or whoever OMEs to develop application towards reactive. Okay, this is a more of a theoretical, and you need not to really worry about it. And just what we need to know is just to learn the essence of what is reactive and everything. Okay, so these are the agenda for today. So when we say there is what actually reactive manifesto says is the these 4. So most of these we were discussed, right? So responsiveness and elasticity, and resilient and message driven. Actually, I have 2 other components that Reactive Manifesto says. The resilient is nothing but the application should be really fault tolerance or whatever you call it. Okay, so message driven is nothing but like it says that a component should be communicate. The action should be on message driven and everything. We'll get to that point very soon. But these are the 4 common factors or traits that Reactive Manifesto actually impose.
Okay, what exactly is like elastic?
Yeah, I'll come to that. Elastic says we have spoken, right? When we have 1,000 members on a given time, suddenly if the peak goes to 2,000, the application has to handle the load without any hustle, without any doing extra stuff and everything. Okay, so the Reactive Manifesto is fine, but what is a reactive system, and what is a reactive programming, and what is reactive model? That's we need to talk about here. So as I said, I'm going to talk much less of Vert.x and more of reactive. So bear with me. So reactive system is nothing but just a system that identifies a state change and just it propagates toward the end of the entire system, and most probably it will end up with a UI change in the client side or a data change in the backend side. Okay, so what is catching here? It is been there for all, right? We are doing almost the same in everywhere, right? So it is actually exists already. Okay, yeah, it is nothing new or new story or just that. Okay, so what is reactive programming? That comes interesting here. So reactive programming is nothing but the way of programming the reactive systems. Okay, so the point is, as of now, we don't have any programming models or not much of programming languages that help you to declaratively write reactive programming. Okay, even if you write some applications in reactive way, the programming pattern or whatever it is, it doesn't really implicitly or explicitly explains this is a reactive or something. Okay, you still don't get what is reactive, right? Okay, so go back to the first one. Reactive system is nothing but when you do something, you need to propagate, and that the propagation will go as a ripple, and it will end up in some actions. That's it. Okay, so when coming back to this, yeah. Yeah, so exactly. That's what the one of the manifestos. Key concept. Okay, event driven is nothing but actually a message driven. So when you event is driven, So it is has to be propagated to other system. How it can be propagated? Only through a messages, right? So the manifesto 1 was actually given as event driven. So they refined that manifesto into a message driven because the event driven is actually achieved by message driven. Okay. So coming back to this, reactive programming is just that programming for the reactive systems. So reactive models are nothing but when we say this is how we want to do, and that can be the same can be achieved in different way, right? So we do one ecosystem do implement their own concept, another one in another way. So similarly, there are so many other models that exist for support reactive programming. Okay, the one is an actor model, and the second one is all well-known callback and promises. Okay, so we know how to handle everything, right? In callbacks and promises, if we do AngularJS, we did already AngularJS. Almost most of us we did. So before getting into all these things, and again reiterating, there is nothing new or nothing fashion. Just that reactive guys put all the facts that we are already doing then and there, put together, and everything as a component, and just all of sudden they wanted to emphasize on all these 4 components are really essential when we build the such resilient or elasticity or whatever responsive modern applications, especially in microservice microservice world. Okay, so what is Vert.x? Vert.x is actually supported or built in the Eclipse foundation. Okay, so and another thing is it is just yet another toolkit. It's not yet another framework. I underline it. It's not yet another framework. Just yet another toolkit built upon Java, obviously. Okay, so it does support polyglot programming. So it's all again unique. If you want, you can go and explore. But it's run on JVM. Okay, so it is actually tend to build such applications which is really distributed. When we say really distributed, it can one component of your application could run in this machine, another one could be run in different world part of the world. Okay, so it is actually really one simple toolkit which will actually enable you to build distributed applications with the help of verticals. Verticals are nothing but just the building bricks of Vert.x. Actually, vertical is nothing but just a class which contains a single piece of code, okay, that can continuously run. So you can deploy all the verticals all together, and you can manage those verticals. And these are the actual building bricks, as I said there over there. Okay, so I come here. This is actually Vert.x architecture. So Vert.x itself, when I say toolkit, it doesn't actually restrict you to do this or don't do this or something like that. Just give you the platform and you can build whatever you want. Okay, so it's just the core itself. It comes with the very basics of HTTP and UDP, TCP connection management and everything, and with the event bus. So event bus is being the core part of Vert.x core, and this is how it enables you to communicate to the rest of the services through messagings. Okay. So that's it. So if you want anything on top of it, there are some components available. You can go and use any of those components and make sure that this is actually aligned with Vert.x core principle, which is non-blocking and asynchronous. Okay. So there are other options available. You can go and execute. You can go and explore it. For example, if you want to web, and you can go and do the web, which means you can build web application like what we do with the Spring MVC and JSP combinations. Okay, so here comes. There is one. We'll come back here later. Okay, so this should be on top of that. So when we say responsive, so when any application should be responsive. So Vert.x follow this principle, no thread per request principle. Now, actually, it's not no thread per request. It's not a single thread per request principle. Okay, that's it. Period. Nothing else. So already Yuvraj has explained so many times how Node.js actually overcome this the Spring ecosystem, right? So Spring, you always have a single thread per request and everything. You all have an idea about what we do with that, right? Okay, so then we'll move on. So Vert.x is also core principle. Also, it is not to support single thread per second. I mean, single thread. Sorry, So how it actually does is like with the help of event loops actually. It manages operating threads, I mean operating system threads with the help of event loops. So probably you also heard about these terms then and there, and you might have used, if you have already used AngularJS, you might have well understood what is this concept. There is a two-way binding, right? Behind the scene, it is actually happening. The event loop is the one actually helps to do the two-way binding. So we have some event providers and some events. When event comes, it actually find a handler and it will attach to the handler and it dispatch it and it will take care of the rest of the events. So it actually in depth actually till the end it will be the same. So at any given point of time, your actual thread is actually busy only accepting requests and it's not doesn't care about how to do that Angular stuff, handler logic or anything, unless and until the callback is written or whatever the point is reached, it won't execute the handler. It will keep waiting. Okay. There is one disadvantage over here, and this event loops can be handled in two different ways. One is actually callbacks, and one is on future objects. Actually, callbacks is one best example that we do. Most of them are used on day-to-day basis, and it has one disadvantages, which already Yuvraj spoke on the other day session, which is known as callback hell. When you go back on multiple level, you have to propagate till then. Okay, so we are very clear why Vert.x is very responsive, because it doesn't support single thread per request. Okay.
So the handlers, they are like on different threads. It can be on a multi-thread.
Yeah, it can be on multi-thread. Thanks for asking. So handlers also, it's a piece of work. There is a two thing. Okay. The one golden rule in here. Yeah, I already have. The one golden rule here in verticals actually don't block the event loop. So when we have we can't say that everything can be handled in an asynchronous way, right? So when you read a file, you cannot do it in an asynchronous way. You need to wait the file system to respond and read the streams, right? So what do? We have something called worker threads, something like worker verticals. You can send those tasks to them. They are actually meant to do the blocking steps and everything. Okay, but still what you do is you have a core, you have a four threads running. The primary threads which are actually taking care of the request from the client, say assuming in the microservice itself, it actually responsible for handling the request, and it will dispatch to the worker thread and it will take care of the rest of the requests. And once the responses came from the worker, then the handler thread will be run. Okay, so there are context and everything associated with the verticals and everything. It's again a shared context or a worker context, and even worker can be multi-threaded. So all like that. So in upfront, it doesn't block. That's the core concept here. So did that answer your question? Okay, coming back to this, how elastic patterns are actually achieved in Vert.x. This is it. So we have one vertical is running, and you can have a several one vertical per thread per core. Actually, you can only have one event loop per core, or you can have a multiple event loops per core. Okay, so this is actually vertical scalability. And if you have so many loads, what you need to do is you can deploy different modules. When we say different modules, you need not to literally go and physically deploy them and add them back to a load balancer and configure all those so-called nonsense. Okay, in terms of Vert.x context. So what it does is it can deploy its own modules and it can cluster them all together. It can support elasticity. That's the concept here. Okay, resilient pattern, again, when we come to fault tolerance and everything, so it is going to be really reliable? No, there is no don't fool yourself. That's a very famous quote used by these guys, Vert.x community. So any application could not be reliable, right? Anything could face whatever, that is disaster time and everything. The one ideal solution is that how fast we can recover from that and how we can basically handle all those things. Okay, so again, Vert.x supports a few. The reactive system supports so the resilient patterns and everything. One is a timeout, and setting a timeout for all other requests that you are sending to other microservice discovery and everything. If the timeout is elapsed, you can come back and report that nothing has been done, and you can retrain everything. Those logics. And something called circuit breakers. Circuit breakers are very well-known this resilient framework. It's been implemented everywhere, most of the microservice things. But Vert.x has own implementation of circuit breakers. It's again just a try and error method, not trial and error. It's try and error. Okay. So vertical failover is just that if you have a multiple components again running, it can just, if it is failed, again you can use any of these two and you can spin that components. Okay, so I talk too much. Okay, I do understand. These are very vague for you. I'm just trying, as I said, I'm not I'm not trying to get you into the core concept of what is Vert.x and everything. But I just wanted to know the theory behind it, because then only we need to know when to pick Vert.x as a solution for our application. Hopefully now you have some idea and go back and work on it, and we can work out, if you're really interested in Vert.x and ecosystem, we can work out on the next sessions on how to do things in every other part. Okay, so we have core concept here, right? I'm going to demo on only one, which is actually a responsive. Okay, so how Vert.x application could be very faster or responsive over the typical Spring application. I'm about to do some very quick example, which will involve a simple hello world. Oops. Do we have time? No. So what I have got here is two code repo. One is Spring demo and one is Vert.x demo. This guy has a controller, usual typical controller. When we say hello, this guy says the return messages, and this guy has the same stuffs. We have something called vertical, so everything extends from abstract vertical. I'll go through the code later, but let's get started with the application actually first. I'm just starting these two guys. Okay, let me close the rest of the applications. Okay, these guys are ready here. Just give me a second. This is from Spring, and this is from Vert.x. No. Just give me a second. Which one is maybe one more. The sentence. Okay, so this guy is actually working. When we have a one request, whatever it is, we have four threads actually, because I limited to 4 threads because Vert.x is going to work on the same, because we have a 4 here. So when on a normal time, these guys together work as cool charm. Okay, so no one actually leads here. So what I also have here is that JMeter. Stay here. Okay, great question, because he helped me here. Okay, so this test script's actually trying to kickstart 300 requests per second, okay, on a given time. So, sorry, 3000. So, we are going to actually load these two guys with 3000 requests per second and see how these guys are responding.
putting a post and put.
Sorry.
Post and put. Where is the post?
Yeah. See, this is actually 1 second. So cursor comments.
Amen.
Okay.
You created 3,000 threads. So because of the
No. Yeah.
3,000 threads in the column.
Yeah. 1 second.
You don't have enough RAM now. Maybe some other application.
Okay. So good.
Okay, let's start.
I think. Okay, these are these two requests actually. So the same guy is hitting both of them.
Okay.
Okay, it's a typical REST and what we do with a postman or something. Okay, nothing else. So this guy has started already. So
Spring demo hits to 80 and the Spring Vert.x demo hits to
81.
81. Open that. Okay, it's slow. That's why. Okay, it's right.
Okay, this guy is hitting 81. This guy hitting 88.
Stop on keyboard.
Here is stop.
Okay.
No, yeah. We have already have enough RAM being occupied with other programs in my machine, so we were able to simulate only 1,000 requests per second actually here. Okay, so let's go back and greet the same guys. This guy is already gone. Maybe because of my mission. But could you see the difference? Not this.
Already your
My browser got blocked.
See,
Yeah.
what you do is stop your JMeter and change the count to maybe 100.
Yeah. Just give me.
The JMeter has the inherent problem because to make an initiative request, it needs to create a thread, concurrent thread first. If the JMeter is written in Vert.x, they don't need to use a thread per module. This problem is there also.
I have already around 80. I have already around sorry Firefox, and I have my visual. I have my visual machine here who is actually monitoring these threads. Let me close everyone. Okay. Okay. So any of you know that we are already using Vert.x here?
How many of you know?
Yeah, that's the question. If anyone knows, except email team, if anyone knows what is the actual product, Panita reads. Stop. No, I changed to 250 actually. Now this guy is running. Okay. Now what I have the problem here is I'm uncomfortable with moving a second monitor mouse. That's it. Nothing else. Okay. Red is actually Vert.x and black is actually this thing. No, it is not updated here, so don't worry about it now. Okay, so I'll restart the demo. Just give me a moment. And meanwhile, do we have anything to discuss here, Murli? Sorry?
The connection, the underlying connection is Reused?
Yeah, reused.
Yeah. Vert.x is not the TCP connection level, it's the thread is getting reused actually. Vert.x.
So the entire purpose is because of better CPU usage, nothing to do with the connection.
No, nothing to do with the connection. Like you.
Yes.
So TCP connection is fine. TCP connection, every client will get its own TCP connection. We have only 4 threads in Vert.x. A typical use case is when a request comes, you fire a MongoDB call and you give a response to it. So if that MongoDB call took 500 millisecond, then what will happen is, let's say we got 1,000 requests. So we received 1,000 requests to our Apache Tomcat, and 1,000 requests are that if you get 1,000 requests at the same moment at the T time, then you need to have 1,000 threads to respond to that. Right? So what will happen is, it's okay, fine, we will take 1,000 threads. It has its own, every thread comes out with stack size, it uses 2 MB or 4 MB of RAM and all of those. But apart from resource constraint, when you receive that 1,000 requests, each request is assigned to each thread. So now all the 100 threads, so each request went to MongoDB. That's what we written. The next in the code, in the servlet code, we have written as make a call to MongoDB. Then let's say MongoDB takes first place, let's say 5 seconds, it took 5 seconds. So all the 10,000 threads are at a kind of a sleeping mode. Basically, it is waiting for the IO. Right? Even though you had 10,000 threads with you, all of them are sleeping. When at the same time, if there is a one more request comes there, nobody is there to serve it. Let's say we put the upper limit as 10,000 threads. Nobody is there to serve the request. That's the whole problem actually. That's why in a typical load, Tomcat and Spring will be able to handle it. When we have too many requests at the same time, we may not be able to handle it because of this. But if you see the CPU utilization, let's say 10,000 requests came, all the 10,000 requests assigned to each one thread, all of them fired a MongoDB call, Mongo took 5 seconds. So during that 5 seconds, if you see the CPU utilization of that machine, it will be somewhere around 1% or something, 0%. The reason is, it's just waiting for the network value. That's the whole point here. So how can it? But CPU is 0%. Still, I'm not able to respond any new requests at that time. For that 5 second of time. How can we avoid that? Because resources are sitting idle, I'm not able to serve the request. So that is where this event, the Vert.x or any unblocking IO comes into. So instead of creating every request from the user, instead of creating a thread, the underlying platform or the framework decides that whenever a Mongo call is going to be fired, that actual thread will be blocked. I mean, that means it will be unblocked, and that thread will be freed. So when it is freed, automatically when a new request comes up, it will be, that thread will be able to pick up. So when a 10,000 request comes, the 10,000 request is one request is assigned to each thread. If you written in, let's say, vertically it won't happen like that. There are a lot of things are there, but let's say in that way. So 10,000 requests, we have a Mongo. So now when a Mongo call happens, all the 10,000 requests are freed. You can think in that way. When a Mongo call happens, all of them are freed. When the Mongo after 5 seconds, when the Mongo gives the response, then each and everybody will be given a response.
So that single thread will maintain the context of all the connections that are open.
Yeah, exactly. So that's the problem comes, right? So now Mongo gives a response, but that response should be tracked to the same thread.
Same request.
Same request and everything. That means the stack info should be there, right?
Yeah.
So those problems are the problems of the platform or the Vert.x. That's where the Vert.x becomes more intelligent. You can track a mapping of for this request. This is the context. So I will store the context everywhere in the context variable. Everything including the request object, response object, cookies and everything. So whenever Mongo gives a response, then we will give a callback to the guy. It comes to the callback one. I think it's a big discussion. I don't want to bypass this, but this is the whole point. So if you have a request thread model, if Mongo is blocking for 5 seconds, no threads are free, no new requests are served, still your CPU is at 0% utilization. With Vert.x, you can
Underlying web server will be the same.
the thread limit.
The underlying web server, right? Will it be the same?
or can it go to
No, it doesn't occur any web server actually. It has own container and everything. Not typically a container. The model itself doesn't require any
Actually,
container.
this guy Vert.x uses Netty.
Netting
That
internal.
guy does a non-blocking I/O. So we won't deploy this into a Tomcat. If we deploy it in a Tomcat, then the threads and the problem is still again comes. So that's why Vert.x comes with its own kind of server HTTP. That's why we see in the graph we can in the diagram we have shown in the core you see HTTP 1.1 and HTTP 2 protocol. So that means Netty itself implements the server. Sorry, Vert.x itself implements it using Netty library.
Okay.
Yeah.
So if I'm building a web application from the scratch,
Right.
so I don't need Tomcat.
Yes.
Yeah.
Yes. We don't need it. Because Tomcat is built with this thread per request model in mind. So that's the main reason. So and also Vert.x needs to own that. Vert.x, this is something core. Let's say there are TCP sockets are there. When I say Mongo is giving a response, that is also going to come through TCP. If I give it that to some other guy, it may not be optimized. I mean, it may not work first of all. So Vert.x needs to handle that IOs. If you have only 4 cores and 4 threads, I always say this because the CPU bound and the IO bound. These Vert.x are very good only if you have IO bound. IO bound means your request actually depends on something from this reading a file or from the network. If it is just a
CPU
computation, right? Then Vert.x doesn't make sense. You can write it in both are same because let's say it's a while true loop for 10 seconds. Then what will happen when 4 requests comes? You have 4 cores, 4 threads will be started in threads. 4 will be using 100% of the simulation of 4 cores. Then Vert.x cannot help them. Even in Vert.x case, Vert.x don't have a CPU to run anymore. Right? So that is something like that.
The only requests are waiting for Mongo response. So will it be?
Yeah, definitely. If all of them are waiting there, then Vert.x will help.
But if so many things are waiting, and if it all comes out, so it has to manage that.
So many threads are waiting up.
So many requests has come, we've accepted most of it.
Right.
And when we are getting responses one
From
by
Mongo?
one, yeah, from Mongo or from other sources everywhere.
Okay.
So that time there will be more load or something.
Yeah, that time there will be more. Obviously, but you will be throttled by the CPU. But our aim is to use the 100%.
Yeah, that's the core
100%
part.
security is the
Yeah.
main thing.
When we go by this other way, it will be whole for ideal for more than us.
That is more, and that's the
Yeah. So any application is actually bound to the CPU processor faster. So yeah, I just ran actually in 300 threads actually. Okay, this guy has a 500 threads already. It's on, and it's been running for more than last 3 seconds. I mean 3 minutes. So let's say read this guy, and this guy is gone forever because
4, 5.
okay,
It's taking time.
we take a lot of time. Never count. Okay, this guy goes. Okay, the same here. Actually, what happens? It take 1 second because I simulated IO operations on backend for both guys as a 1 second. So what it actually happens, as Yuvraj said, the 1 second both are going to have that IO operations. Okay, but when this guy is coming back here, Vert.x guy is coming back here, the CPU is available. Okay, so he can compute the response and he can send it back. But whereas in Spring, see, this guy is still loading. No? What happens here is even every 1 second, every request actually blocking the CPU for every 1 second. So 500 requests per second, actually 500 already callbacks are being assigned, and all of them are queued, and they block the CPU for 500 into such this number of seconds going right now. So the CPU is unavailable for the rest of the requests, so hence it's got blocked.
I think it's not CPU available, it is threads.
Threads, yeah.
threads are not.
Threads are
When
not.
we
CPU
say-
is completely underutilized.
Threads
Yeah.
are not available.
Yeah, thanks for that. So that's it. So one such example. So even with this mind, as Yuvraj said, if you have an IO bound operations in application, you can go and build all these in Vert.x. And if you can, any doubt, we can come back to me and we can discuss on this more. So anything else we have to discuss here?
For 1 second,
IO obviously is taking this much time to complete.
Yeah, because the resource is limited. I have limited with 4 threads actually.
Actually, I failed. By this time, they should have failed because we didn't set the request time of the browser. Browser
Yeah.
don't have a request time. But the point is, 1 second, why still it is taking time is, it is trying to find a thread, free thread. The browser request is like, already on the 300 limit
500. 4 threads actually.
4 threads. Spring learning deploy பண்ணும்போது, you can say Spring or Tomcat, anything you deploy, you can say max number of threads you can create. எதுக்காக அந்த லிமிட் வைக்கிறோம் அப்படின்னா இந்த மாதிரி கன்கரண்டா ஹிட் ஆச்சு அப்படின்னா your Tomcat should not end. Instead of that, you better not accept the request. Better don't accept the request. Better to don't accept the request than dying the whole container. அதுக்காக அப்பர் லிமிட் நீங்க வச்சு ஆகணும். சோ இப்போ வந்து இவர் என்ன பண்ணிருக்காருன்னா 4 மட்டும் செட் பண்ணிருக்காரு. 4 thread அப்படி. It is hitting concurrently. So those 4 threads are already given to the JMeter. Too much request வரனால it's already those are already blocked for those requests. So this request from the web is not getting the thread. So this will keep on waiting for a long time. அப்பதான் கேப் கிடைச்சு ஒரு thread free ஆகும்போது இந்த request assign ஆச்சுன்னா you will get the response. அந்த graph உங்களுக்கு காமிங்க அந்த response. And PayPal recently built that whole thing using this not Vert.x, they used Play framework, hacker model. But the point is that also uses the same what Vert.x has. இது பாருங்க நீட்டா ஓடுது பாருங்க.
See, literally this guy has expand this.
Demo is success.
Thanks for declaring it. So obviously it takes around 120 seconds to respond, where this guy is less than a second. I mean actually around 1 second because we already have 1 second IO simulation. So that's all. So
both of them have even only
Vert.x actually processes 1 criteria of a reactive system, and the rest of 3 actually we need to build upon it. Natively supported by Vert.x. That's the core concept. Okay, guys, thanks for your time. Thanks for.
So we didn't address the callback bill. That will be solved by this.
Call back Helen. This one?
In Vert.x.
Okay.